Hi, this is Philip Winston of Tobeva Software. I'm going to be showing a demo of how we are adding a WebUI to an existing Python application using shared memory. The application is Napari, a multi-dimensional image viewer for Python, and the WebUI add-on is totally experimental right now. It's in the very early stages, but it's pretty interesting to see how it works, and it's something you can play with and extend on your own. So let's talk about native versus WebUI. So a common way to do native is you have a lot of common code that you're hoping will run for all the applications, but then you have portions or little stubs or sections that are specific to each UI and each platform. So Windows, Mac, Linux, iOS, Android, if you're doing mobile. So more commonly, you have a multi-platform framework so that you don't have to write those platform-specific code. So for Napari, they're using Qt, which is older but pretty powerful framework. There are a lot of newer frameworks as well. Lots of companies are doing still multi-platform development for native. In fact, in the mobile world, native is pretty much standard. You know, if you're going to use any kind of web service, they're going to ask you to download an app. So native is extremely popular and still very common. However, there is another option. So what can you do for multi-platform is you can use web technology. So you can use a web browser, either a literal web browser or something like Electron or some kind of embedded web browser. So web browsers are pretty much operating systems. They're more complex than operating systems were not that long ago. They contain, process management, memory management, network management, small databases, file utilities, very fancy and extensive JavaScript interpreters. It really is just an amazing piece of technology. And the reason is there's this huge economic incentive to advance these technologies. There are 4.5 billion internet users, right? So that's pretty amazing pressure to advance these things. They contain graphics engines, they contain GL, they contain vector renders, a huge toolkit, and most centered on user interface. You've got the core technologies, HTML, CSS, JavaScript. Chrome has the V8, JavaScript engine. Firefox has a very advanced engine as well. You have front ends like React, Vue, Angular. You've got JavaScript visualization like Vega-Lite, D3, Bokeh, WebGL, DeckGL is from Uber, large scale visualization. And now you have WebAssembly, and WebAssembly is going to let you have other languages like Rust and C++. So it's a thriving ecosystem, very advanced, lots of users, lots of developers. It's really impressive. If you haven't dealt with a lot of web technology, it's an amazing ecosystem. Here's just giving you the timeline. These are the core 3 desktop platforms, Linux, Mac, and Windows, when they came out. So that's good 35 years ago. And then the modern browsers are all much, much newer. But as I said, native is definitely continuing indefinitely, but web is also sort of rocketing forward. So should you do native UI or web UI? So if your application is big enough, I think it makes sense to have both UIs. If you don't have enough developers, then obviously you probably have to focus on one or another. But as your application grows in sophistication and size, and if you're able to attract open source developers, I think it makes a lot of sense to have web UI. Now, the people that are familiar with these technologies are different. People have different career paths and career plans. So if you let your contributors decide where they want to add the UI, I think that might be the way to go for a large application. So Napari is a desktop application today. It's written in Qt. It has a lot of data. It loads images and geometry and even videos. And what we can do is using Python's shared memory features, which were greatly enhanced in Python 3.8, and they fixed some issues in Python 3.9, and we can copy data into shared memory. And so right now I'm only copying dictionaries and lists and things, but they have the ability to integrate very tightly with NumPy. So you can create a NumPy rec array, basically have structured data of any type and copy it into shared memory in bulk. So we want to demonstrate that soon, but right now we're doing sort of smaller metadata type things. So webmon is a process. It's a small Python program, a couple thousand lines. It has 2 parts inside of it. One is a shared memory client, which is kind of a wrapper on top of the Python built-in shared memory features, and it knows about different shared resources that that Napari exposes, mainly a shared dictionary and two shared queues to pass messages back and forth. And then it has a web server. The web server is a Flask Sockets.io server. Using WebSockets, Sockets.io is really important here because we want an interactive experience. We want to be constantly sending data between Webmon and the web browser. So on the right-hand side, that's the tile viewer, which is basically the first thing we made for Webmon. And the motivation was to debug and develop the Octree feature. We wanted a way to display the tiles, and we didn't want to do it inside Napari. We actually did it that way at first, but we decided to do it externally. And so the data here flows from left to right, and in fact in the other direction as well. So basically Napari is writing into its shared memory at about 60 hertz. Webmon is reading it out of shared memory around 60 hertz, and the web browser is fetching it from the web server at about 60 hertz. So it's a very fluid connection. We'll see how much data we can actually send back and forth before that's an issue, but there's a lot of tricks and things we could do. Here's the steps I'm going to show. I'm starting from scratch because I want someone that's not familiar with this to be able to get up and running. So I'm going to set up Conda and Git. I'm going to demo the existing Webmon. This is what's in the repos right now. And then in Napari, I'm going to add, in a branch, I'm going to add a new points message for the points layer. And then in Webmon, I'm going to add a points tab in the WebUI. And this points display is going to be very simplistic, and it's not really meant to be useful or to perform well with a lot of points, but it's just to show the steps. It's just something simple and graphical I decided we could do. That's what we're going to do. Let's get started. So I'm starting totally from scratch. So we're going to make a demo directory, and there's nothing in there. I'm going to pull up the website for Napari's GitHub, and I'm going to get the link for the Git repo and clone that. I'm using SSH for GitHub, which is nice. You don't have to enter a password. I'm going to get Webmon. This is on my account right now. Hopefully it'll get switched over. So clone that. So Webmon is a much smaller project, you can see. So let's close this up. So now we need a Conda environment. So Conda is how we isolate the Python dependencies, including, in this case, the Python version. We're going to create an environment with Python 3.9 because we need that. Webmon needs that for the shared memory features. They debuted in Python 3.8, but they had issues, and so we use 3.9. So I'm going to activate that. So now we're going to install Napari. Normally you would pip install Napari from the internet, but we're going to do it from this local files that we just cloned. -E means make it editable, which means it doesn't copy the files into the site packages. It allows us to actually just edit these files and run Napari, which is basically how we need to do it to do any kind of local development. So Napari has a lot of dependencies, as you can see. It's going to install all of them. Obviously, we have NumPy and IPython and Jupyter Core and PyOpenGL, NumPy doc, all kinds of stuff, although they do try to keep the dependencies down. So let's see if we can run Napari. For some reason, it doesn't run the first time. So we're going to run it again. And now it's saying we need either PyQt5 or PySide. So for Octree, you need PySide 2. In fact, for a lot of features, you need PySide 2 right now or it'll crash. So unless they fix that. So we're going to get PySide 2 just to be sure. PySide 2 and PyQt5 should be equivalent. They're really the same thing, the same purpose, which is a Python interface to Qt. So let's try it again. So it works. We get a warning, which I'm going to just do what it says, Conda install Python app. So I'm not entirely sure why this is necessary, but let's just see if we can get it started up warning free. It'll just make us feel better. So just install what it says. Let's try again. Great. So the splash screen is coming up on my other monitor, but Napari is running. All right, now we want to install Webmon. So we go to Webmon and we install this. If you look at the README, with requirements txt. So similar idea, but pip install is not set up for Webmon yet. So I can cat that requirements file, and you'll see the big one here is Flask socket.io. These are required for Flask socket.io, NumPy. Eventlet is an asynchronous framework that you need. You need some asynchronous framework, and then click is just command line. Let's see how we can get Napari to run with Webmon. So by default, obviously it does not, but we can create a config file anywhere. So this config file will be passed to Napari, the path of this config file passed to Napari when it loads. And it specifies a log file that Napari will use for the monitor related features. Monitor is the name we use internally for the shared memory features. In a way, it's really just a type of plugin system, right? It's just a way to tell Napari what sort of plugins, multi-process plugins to run. But we call it monitor just for historical reasons. So the second part is a list of clients. So you can actually have many shared memory clients going at once. Each list just contains the command line and the command and the argument. So I have the full path to the Conda environment Python interpreter because I found that was necessary at one point. So I've just kept doing that. Basically, inside of Conda, you launch Napari, and then Napari launches Python, and somehow it was not picking it up unless I did this, maybe pathing issue or something. But this definitely works. Webmon is the program we're running, and then the Webmon program has a path that you can give it. And so we have these two log files that we'll take a look at and are sometimes really useful for debugging. So this file looks correct. So let's go ahead and try to run Napari with Webmon. So first of all, we need to turn on Octree features because that's the main and really the only, the main feature that produces any kind of WebUI. And then the monitor file that we were just looking at, and then Napari. And then I'm going to paste in this address of a deep zoom image. So this is a URL where a deep zoom image is an older Microsoft format for multi-scale images. And I knew this was going to happen, so no plugin found capable of reading deep zoom format. So this is a plugin that we need. And so Napari DZI ZAR. So this will allow Napari to read deep zoom formats and display them with Octree. So we can try that again and see if it'll load. So there it is. Great. This is Napari running Octree code, viewing over the internet. So if we look at the console, we see it said starting up on 0005000. So that is a localhost address. So we can go ahead and bring that up. I have this viewer specified. This actually is stale, I think. Let me do something here. You'll need to know how to do this. So you can turn on these developer tools and then right click here and do hard reload. And this is what I wanted to show you. So this is what you'd actually get if you followed the steps, right? You get this crazy big logo. And what you're seeing here is viewer loader is, there's no CSS here. It's just, and in fact, there's no JavaScript. It's just like the HTML from Webmon. And so the reason was I purposely didn't do a step that you need to do. So let me split this. And over here, we're going to go into Webmon. And this was in the README, but I just wanted to show that what happened. So if you have to do make build. So this is a node build step that will fetch the remote packages for three.js and for Tailwind, and it will build the local modules that it needs. So the nice thing about this is we can just go here and reload, not even hard reload in that case, and now this should be live. Let's see if we can get them both on the screen. So yeah, so this is live. So the nice thing about that is we actually, rebuilt Webmon and we didn't restart Napari. And we'll see this later also. This is like a really nice feature of having WebUI or two UIs or process plugins, is that when I was developing this tile feature, I had to work on it all day, rerunning it like 50 times during the day. And I never restarted Napari. I just had Napari, and I had it actually zoomed in on something, and I was just leaving it there all day. And in that sense, Napari becomes kind of like your IDE or your OS, right? It's just there, and the program you're working on is just the web part. And so you iterate and iterate, and it's a really nice productivity boon to have essentially part of your system stable and working, and then the part you're working on is smaller. So this is great. We have Webmon running as it is today. You can see the yellow is the view frustum, the red are the tiles that are being drawn, and this is totally smooth. It runs at 60 hertz. So this is what you get out of the box with Webmon today. You have another tab over here, which is these, we call it the loader. These are related to the chunk loading. And so this is the number of milliseconds per frame. You can see it's mostly under 20 milliseconds until you do something at least. Milliseconds per chunk. The minimum I got here was 200 milliseconds. Maximum was over 600. This is for the remote tiles. And the bytes per chunk is kind of interesting because it's almost always the same, but then you have these edges and corners can be smaller. So these graphs are with Vega Lite. We think we might also try Bokeh, but this is illustrating three.js, WebGL, and this is illustrating 2D WebUI. And so they're both getting data directly from Napari. So now we want to actually make changes to Napari. So let's exit Napari and let's start VS Code to make some changes. All right, let's start VS Code and we'll look at both Napari and Webmon. So we've got two directories here, Napari and Webmon. We're going to look at the shared memory features of Napari. So let's look at, I think it's under Napari, and then components, and then experimental, and then we have monitor, and we have remote. So what is the difference? Monitor, again, that's kind of the historical name for this shared memory. Monitor does not depend on Napari at all. In fact, if I were going to add this shared memory to another application, if it's open source, you could start with these files or just, get inspired by these files, how they work. So basically there is a monitor service class that gets started, and it's going to look at that .mon file that we created, and it's going to start the external processes, and it's going to expose, let's see if we can find the resources. These are the resources. So there's a dictionary that can be used to send data back and forth. I think we only send it from Napari right now, but there is a queue for Napari to send messages and a queue for the client. Oh, we have a dictionary for the client too. So the Napari has a dictionary, a queue, and an event, and the client has a dictionary and a queue. And basically we use the dictionaries to just sort of broadcast messages or metadata or information. And we could set up a system so it only does that if the connected client is requesting it, so we don't waste our time, but I don't think we've set that up. But it could be the case that like a client connects and it says, I want to get information about your memory usage, and then you start putting that in there. The queues are for events that you do not want to miss. So dictionary, it's just writing in every frame, and maybe the client reads it, maybe it doesn't. Queues, the client will empty the queue. It will get every message. And so the main thing we use that for right now is when you click on the client to toggle the grid, we send that in the queue. So anyway, these are the basic resources, but this doesn't depend on, except for the name, it doesn't depend on Napari. And then this remote stuff is sort of the API to Napari. And so remote commands are what the client can do, which right now is really just this show grid toggle. It shows how you could easily add other commands. And then the messages is what Napari sends out, which right now it's just this on poll message and the frame time. So that's what we're going to look at now. So on poll means every frame, 60 times a second, if it can go that fast, it's going to send a message to the client that looks like this. So dictionary of the layers, and then it's got the layer ID, and then it's got whatever messages that layer wanted to send. And right now on the client side, we actually just look at the first layer. We don't have UI, but you could have UI that displayed the list of layers and stuff like that. So where is this message coming from? Down here, it says, hey, go through all the layers, and if it's an Octree layer, call the remote messages attribute. If we put a remote messages in the base layer, then we wouldn't need to check the layer here. We could have it just return null, but I didn't want to make that change because it's kind of a global change. So right now we check. We want to do something for the points layer. So here's how we're going to do it. So rather than just clutter it in here, I'm going to say if has messages layer. And so now we're going to make it a little more generic. So if we have messages for the layer, so then we're going to say right now if it's an instance of Octree image, and then or if it's a point. So I think point layer is just called point. So that's what we're calling it, and that's what we call it. So hopefully this will call the remote messages attribute for point layers. So save that. Oh, I didn't make a branch. That was a mistake. Let me see if I can. How am I going to undo that? Let's go to here. Let me just copy this and go undo. And then go to the shell, and we'll make a git checkout branch and demo WebUI demo. Okay, so now go back here. I'm sure there's an easier way to do that, and we'll just make sure I did it right. Check, yeah. So this one filed exactly what we wanted. So let's go to the points. So, well, actually, let's go to the Octree image to show how that works for us. So Octree image, if we go to the bottom here, we have remote messages. So this is the attribute that the messages code is calling. And it says, hey, if we have nothing, then return nothing. If we have no intersection, return nothing. Otherwise, ask the intersection for its tile state and its tile config. So let's go to Octree intersection. And what was the name of that function? Well, it's just tile state. So let's look for def tile state. So here it is, this property tile state, and it's using this mgrid stack thing to return a list of row column pairs of visible tiles called scene, and then the corners are in the data coordinates x, y, x, y. And then the second one is the config, and that has a bunch of stuff related to the arrangement of the tiles. And so if we jump ahead and look all the way at viewer.js inside of Webmon, we can see, if we search for tile config and tile state, we can see this is where the JavaScript is getting those exact same dictionaries. And in this case, I'm making a little object with them. So if we look for class tile state, this may or may not be the best way to do it, but we're getting this message. We're making a map of which tiles we've seen, and there's a bunch of code in here to do. Oh, here's the other methods. Was this seen? What's the minimum? Oh, context is an area around the tiles that we're going to draw. So this is this nice pathway, right? This tab is Python in Napari, and this tab is JavaScript, and it's the same, the same structure. So let's add the points. So we go to the points, and let's see, in Octree, it's going to be the same. So we'll say, just copy this and do it like that. And then I'm just going to cut and paste it in here. So what we want to do is return a dictionary, which has one key, which is points. We convert the points in the data into lists right now. They are NumPy. You can send NumPy across with messages, but I ran into some issues. So the way we really want to do this is with just a total NumPy array. That is going to be the highest performance. This will fall apart. We don't want to send the points every frame, but this is just for a demo. I mean, really, you'd want to somehow synchronize up with the client and only send the new points or something like that. But this is just the dirt simplest thing we could come up with. Let's go back to our Git and see we have the messages, the 2 changes there, and we have the points, the change there. Great. Let's run that and see if we get anything. Okay, so let's see if it's going to print out our log, our points. So run it again, and we don't have any WebUI. Okay, I have syntax error, line 16. I think I know what I did there. So we're in the messages file. Okay, so yeah, I say if is instance, this should be return. And then I can see that this point is not working, is not imported, so it should be points. And then I know we want to fix this points, import points from points, import points. So let's try it again. This is, again, we added the message to send out the point information. So first, let's just look at the log. This is for the Octree. It's kind of neat. You can see the corners change like that. But let's delete that layer and let's do the points. There it is. Points is empty, which is what you'd expect. And as we add points, we get more points. So this is good. Now we need to do the WebUI part. So on the WebUI side, this, is more experimental because, you could do any WebUI, you could use any framework. Once you get past the shared memory part, you can do anything you want. But right now, this is how we have it set up. So basically we go into this, well, I guess I can do it from VS Code. So basically, here's how it's set up on the VS Code side. Okay, here's how it is on the VS Code side. Webmon, we have this bridge, handlers, and the client. So the client talks to Napari, the handlers are the web server, and the bridge is kind of passing data in between. And then we have templates here. So this base template is the HTML and the CSS for the tabs. And then we have a loader specific one and we have a viewer specific one. And so we're going to make a copy of the viewer and we're going to call it points. And we're going to call it points and we're going to go into that. It extends the base, which is correct. It has a WebGL. We'll leave that there. This input, this whole input is this UI. We're going to get rid of that. We're not going to have any UI to start. That's our web container. And then we call start viewer from viewer.js. We're going to call start points from points.js. So this is our tab. This is the new tab. We also need to actually call start points. Now we need to tell Webmon about this new page. So we go to the Webmon PY, which is like the main one, and it will create routes sort of for each page in this array. So all we need to do is add points to there. So let's see what that gives us so far. I know it's not complete, but let's run Napari again and go to our WebUI. And now we have this points tab. And we click on the points tab and let's look at, there's nothing there. Let's look in the console. And it said failed to load resource static points.js. So that makes perfect sense because we did not make that yet. So let's quit here. Now we need to make the JS file. Okay, so it's missing static/JS, but if we look at those files, we'll see they have all this crazy stuff in it, right? So these are actually the files that get built by the build step, and it's kind of an agglomeration of every dependency it needs. So we actually don't want to edit those. We want to edit from the JS directory. So here in source, we see the viewer. It's about 500 lines long. So we're going to make a copy of that. Now, I don't really recommend this as a great example of three.js code at all, but it proves the point. It does display. So we're going to make a points.js, and I'm going to go in here and just hack out almost everything from this file. Okay, hacked out a lot of stuff, and now we're going to create points, and we're going to leave this the same. We're no rect, no axes, add lights. Okay, draw points. Okay, this is now draw points. This animation frame is how it draws at 60 Hertz. We're going to make a new function here just called update. And get rid of this. And I don't think we have controls, but we'll just leave that. Set up controls. No, we don't have that. Start points. Okay, I'm going to paste in some functions I already wrote. So let's see. Create point. This is, okay, so this is not supposed to be a demo about three.js, so I'm just going to zoom through this, but this is just to show that you can manipulate the data. So creating a point at some row column position. Okay, finding the bounds. This is a little tricky how you do these destructuring, but basically this is just going to find the XY bounds of the lowest and the highest point. And this is our update routine. I'm going to just go through it. If we don't have any points, like we're not viewing a points layer, then just do nothing. Otherwise, get the scene graph parent, remove anything from that parent. So here we're resetting everything every frame, which is not a good idea. If you had a lot of points, you'd want to do some kind of set delta, like what points do I have so far? What points are missing? What points need to be removed? That kind of like set delta synchronization happens a lot in graphics, where you just like do these set operations and figure out what's new, what's old, or what's new, what's going away. So find bounds is the routine we wrote. Get the width, figure out the scale. We're going to scale the points. Currently, this is set up for like 0 to 1 coordinate, so we're going to scale the points down to 0 to 1. We're going to translate them. We can't do this with one transform because the order of translate, rotate, scale, at least I don't think we can. So we're going to shift it over by the bounds to get it into the 0, 0, and then scale it to be 1. And then we're going to actually add the points, create point. So that's it. That's our new points UI. So let's see if it works. Okay, so let's run with our new points UI. I forgot I had to, if I made this or not. So let's build it. Let's run Napari. We'll see what we got. So Napari is emitting point messages. The webmon Python is just passing them through, and the WebUI, the points JavaScript, is going to be displaying them. So let's find our web browser, bring it up. This is the same. Delete this guy, bring up the points. I'll bring up the points over here and start adding points. Now this, I think the camera is zoomed in. We don't really have camera controls set up correctly, but it gives you the idea. I don't know if you're supposed to double click or what, but so there we have it. So this is Napari on the left and WebUI on the right, sending messages about points that are being added, that are being sent over WebSockets and being displayed over here. So I will put the code that I ended up with in branches so you can look it up. But basically, that is the idea. So yeah, we did all these 4 steps, and I guess I just want to say, if anybody's interested, it's all out there. It's all open source, so you can contribute or play around with it, make branches, do whatever you want. Let's see if I go back to the beginning. Okay, thanks for watching. This is Philip Winston, Tobeva Software, and talk to you later.